Okay, so this video is kind of our accumulation of everything, which is taking some word problems, writing some system of equation to represent it, and then solving that system to find the actual answers. So I'm going to do this video a little bit differently. We're going to practice setting up the systems together and writing them down. And then afterwards, I'm going to have you go back on your own and try and solve and see how you do with them. Because really just the writing of the system of equations is our new skill here. So number one, we have Chelsea and Jessica each improved their yards by planting daylilies and ivy. They bought their supplies from the same store. Chelsea spent $53 on 13 daylilies and 2 pots of ivy. Jessica spent $105 on 14 daylilies and 9 pots of ivy. What is the cost of 1 daylily and the cost of 1 pot of ivy? Before we start jumping into our equations, I find it helpful to decide what variables we're using, and I write down, what they are representing. So you are welcome to use X and Y still. We've been doing all of our systems with X's and Y's because it corresponds with the coordinate plane. But when it comes to word problems, I tend to use letters that represent the things I am talking about. Just helps me realize in the end, when I go to give my final answer, what was representing what. So here, the question asks us, what is the cost of 1 daylily and the cost of 1 pot of ivy? So I'm going to say, let's let D, oops, here fell. D is going to equal the cost of a daylily. And notice I'm not just saying daylily, I'm saying the cost of a daylily. And I'm going to say I is the cost of an ivy. And now those are the 2 variables I'm going to use as I make my equations here. Now, this type of question, we have 2 different people buying the same 2 items, but in different quantities and spending in a different amount of money. So we are going to set this up as, what did Chelsea spend? And what did Jessica spend? Well, Chelsea bought 13 daylilies priced at D dollars each, so we can say 13D, and 2 pots of ivy, so plus 2I, and she spent $53. Jessica, on the other hand, bought 14 daylilies and 9 pots of ivy, and she spent $105. I'm just going to fix this 4, and those are our 2 systems, our 2 equations that make up this system. Okay, we wrote an equation for how much Chelsea spent and an equation for how much Jessica spent, and then we would go through and solve this. For now, we're going to move on to number 2. Over the last week, Anthony sold cookie dough as a fundraiser for the football team. He sold 21 packages and collected $322. The oatmeal raisin cookie dough sold for $15 per package, and the double chocolate chip cookie dough sold for $16 per package. How many of each type of cookie dough did Anthony sell? So just like before, I'm going to say what my variables are, what they're representing. I have oatmeal raisin. I'm not going to use O for oatmeal raisin. That looks too much like a 0. So I'm going to say, let's let R equal the oatmeal raisin. And what about it? It says how many of each type. So unlike the last one, which was cost, I'm going to say R is amount of oatmeal raisin. And then for chocolate chip, I'll say C equals amount of chocolate chip sold. Okay, so now let's see what equations we can come up with. Now, I will say in all my years of teaching this, most people can easily find the one equation, but have trouble with the other one for some reason. The one I usually get is 15R, because we bought 9 packages of oatmeal raisin for $15 each, plus the 16C, it's the $16 and then the amount of chocolate chips, equals $322. So that kind of has to do with the money that was raised, or the values of the boxes that were purchased. However, we also know that there are 21 packages. And keeping in mind, if we go back to how we defined our variable, R is the amount or the number of packages of oatmeal raisin, and C is the amount or number of chocolate chip packages that were sold. So if we're talking about the number of packages, our equation is actually very simple. It's just R plus C, bad plus sign, R plus C. So the number of packages of oatmeal raisin, the number of packages of chocolate chip altogether have to equal 21 because there were 21 packages. So one was based on money, one was based on number of packages. There are our two equations. And then number 3, the employees of Six Flags Great Adventure were cleaning the park over spring break and found $8.05 in quarters and dimes. They found a total of 55 coins. How many of each coin did they find? So I'm going to say Q is number of quarters, and D is number of dimes. Okay, and we have $8.05 found and 55 coins total found. So let's do the number of coins first. So the coins, they found 55 of them. It was quarters and dimes. Our first equation is just going to be Q plus D equals 55. And then we have to talk about the value of those coins. Okay, so over on this side, I'm going to throw my $8.05. Okay, that's the total value of the coins. But now when we go to put our Q and D on the left-hand side, since we're talking about the total value, we have to incorporate the value of quarters and dimes. And this is where I don't give you this information. I assume you know this, that a quarter is 25 cents and a dime is 10 cents. So if we know Q is number of quarters, if we want to figure out how much money our quarters are worth, we would do 0.25 Q, 25 cents for each quarter. And this plus 0.10 or just 0.1, it doesn't matter, but 0.10 times D. You could, if that bothers you and you don't like the decimals, okay, you could do 25Q and 10D. But now, since you're really saying like this is cents, on the other side, instead of saying $8.05, essentially you have to change that into cents, which would just be, as crazy as it might seem, 805 cents. So it's either like you need the decimals for everything or you don't use decimals for anything. Okay, you can't mix and match there. But either of those two equations for the value is fine. So those are 3 systems. Okay. This is going to be where you go back and solve them. So just to say, what might be the best way here, notice in number 2 and number 3, even though we don't have R equals something or C equals something, okay, we have, R and C that could, or Q and D and the other one, that could pretty easily get by itself. So I'm thinking for number 2 and number 3, substitution might be the best method of solving there. Could technically use elimination. It's not that it's wrong. And if you choose to do that, that's fine. But I'm thinking substitution, probably the best for number 2 and number 3. Number 1, I don't have just a D or an I. I have coefficients in front of them. Trying to get a D or an I by itself there probably is going to be kind of gross. So I would say for number 1, elimination is probably your best option there. And notice that, 13 and 14 don't really mix and match. 2 and 9 don't match. They can't go into each other. So this is one where if you're using elimination, you're going to have to multiply both equations by something to figure it out. So I'm going to ask you to pause. Okay. Try to solve each of these. And then what you can do is you can kind of fast forward to see what the answers are. I'm going to go through them now, but you can fast forward to what the answers are so you can check. And if you need to then, if you get something wrong, you can go back and look at the actual solving of that question. But from now on, please don't feel like you have to watch the rest of this video unless you need to. Okay, so pause and try, and then do what you need to. Okay, so for number 1, we said elimination is the best one here. I'm going to focus on the I's because my numbers are a little bit smaller. Okay, so I'm going to take my first equation and multiply it by 9. And I'm going to do my second equation and multiply it by 2. And I'm actually trying to think. Let's see what happens. I know normally I like opposites, but let's look at what happens here. So now we have to multiply the top one by 9. So that gives us, and calculator's totally fine, 117D plus 18I equals 477. And if I do my bottom one by 2, I get 28D plus 18I equal to 210. So even though I didn't do opposites here, it's not so bad because I can now subtract. Ooh, that's really big subtract sign. Let's change that thickness there. So we're going to subtract here. So 18I minus 18I is 0. 117D minus 28D is 89D. And then this one is 267. And then if we divide, we get D equals 3. And now I could plug that in to find my other information. I'm going to plug it into the top one because my numbers are smaller. So 13 times 3 plus 2I equals 53. That's 39 if I do 13 times 3. I'm going to subtract my 39 to move it over. 2I equals 14, which means I is 7. And I should have mentioned this before. That's silly of me. But in the end, with our word problems, okay, we're not going to leave it like this. We're not going to write it as an ordered pair. We're going to answer the question. So it wants to know the cost of each. So I'm going to say a daylily is going to be $3 and a pot of ivy is going to be $7. So I'm going to label my answer so I can clearly see what my answer is. Okay. For the next one, I said substitution kind of looks good to me. So I'm going to say, let's get the R by itself by subtracting C, which means R is 21 minus C. And now I'm going to plug that in to the R in the other equation. So instead of 15R, it's going to be 15 times 21 minus C plus 16C equals 322. If I distribute, we end up with 315 minus 15C plus 16C equals 322. I'm going to combine my C's together, which actually works out nicely because it's just one C. And then I can subtract my 315 to move that over. And C is 7. And I'm going to plug that into this right here. So that would be R equals 21 minus 7. And then R is 14. So we have 14 oatmeal raisin. Remember, it's not the cost. We were looking for how many were purchased. So 14 oatmeal raisin were purchased and 7 chocolate chip. And if you use elimination there, like I said, not that that's wrong. I just thought substitution was a little bit easier. Obviously, your work for elimination will look a little bit different, but your answer should be the same. Okay, and this one, I'm going to use substitution again. I'm going to get D by itself. You could do Q, doesn't matter. I'm going to do D. So that would mean we subtract Q, and this one turns into D equals 55 minus Q. And we're going to deal with some decimals, but we have calculators, so it's okay. So I'm going to take that and plug it in for the D in that equation, which is 0.25Q plus 0.10. Going to multiply by the whole thing of 55 minus Q. So we use parentheses equals 8.05. We distribute. So that's going to turn this into 5.5 minus 0.1Q equals 8.05. I'm going to put my Q's together. So 0.25 minus 0.1 is 0.15Q plus 5.5. I'm running out of space, so I'm not going to show up, and I'm going to, I got a little bit of space. I'll subtract my 5.5 on both sides. So 0.15Q equals 2.55. And if I divide by 0.15, I get Q is 17. And since D is going to equal 55, which is the total, minus 17, we get D is 38, which means final answer is 17 quarters and 38 times. And that is how you set up and solve systems for word problems.